Hello everyone. In this video we're going to be solving a very interesting trigonometric equation. Why would this be so interesting? It looks so simple, right? So pure and simple. Cosine x equals 2. The problem is, what makes it interesting in my opinion is that cosine can only take values between -1 and 1 inclusive. So we've been taught all this time that hey, cosine x must be on this interval, and we have this famous identity sine squared x plus cosine squared x equals 1. Therefore this also indicates that for real values they have to be between -1 and 1. And as you know, on the unit circle, those are the boundaries. Like we have the pi over 2, the pi, and the 3 pi over 2, and the 2 pi. That takes those special values. All right. So in this case, if cosine x is equal to 2, then cosine squared would be 4, and sine squared would be negative, which is fairly interesting because sine squared is supposed to be non-negative. Okay, anyways, let's go ahead and solve this equation. Obviously, the solutions are not real. Therefore, we have to take a complex approach. So, thanks to Euler, we have a very nice identity, which is given as follows. And by the way, in order to show you that we don't have any real solutions, I graphed it for you. I kind of like the graph that Wolfram Alpha gave me because it is kind of simple, and you can hopefully clearly see that the horizontal line y equals 2 does not intersect in any way, shape, or form the graph of cosine x. Therefore, no real solutions. Make sense? Okay, let's go for the complex. So we have these beautiful identities. E to the power ix equals cosine x plus I times sine x. This is very nice because it allows you to write a complex number in polar form and then also turn it into an exponential form. Obviously, the exponential form is much more compact, and calculation-wise, like if you're multiplying or dividing, it makes things a lot easier. It also explains why the arguments, the x's, are being added or subtracted upon multiplication and division. Alrighty, so here's what we're going to do. We're going to get a variation on this formula. What happens if I replace x with negative x? One of the fun things about formulas in math is you can basically play with the formula, replace x with some special values. It could be 0, could be 1, could be I, could be pi, anything. And negative x is one of them. So we're basically testing what is going to happen if x is replaced with negative x. We get e to the power negative ix. Now cosine of negative x is, let's write it first and then I will simplify it for you. Now cosine is an even function, therefore cosine of negative x is the same as cosine of x, but sine is an odd function, so sine of negative x is going to be negative sine of x. So I do need a minus sign here, minus sign, the sign S-I-G-N in the middle. Make sense? So why did I write these? What does this have to do with cosine? Well, hopefully you can see what I see. Look at these equations very hard if you haven't seen it already. I have cosine x in both of them. And guess what? If I add these two equations, sine x and with the I is going to cancel out, leaving us with something very clean. E to the ix plus e to the negative ix equals cosine x plus cosine x, which is 2 cosine x. And then divide both sides by 2, and you got a beautiful formula for cosine of x. This is also nice because when x is real, you get e to the ix, which is complex, e to the negative ix, which is complex, but their sum is real because they are conjugates. Make sense? Obviously, they do cancel out. Cool, cool. What happens if x is not real? Like, let's say x is equal to I. Then you can also find the value of cosine I here. Obviously, that is going to be real as well, right? Because e to the power I squared is going to be e to the power -1, which is 1 over e. So that's kind of interesting. We don't seem to be getting a complex value from cosine x. So is there a solution to the equation cosine x equals I? Who knows, right? Something to think about. Anyways, that's not our topic. So let's go ahead and focus on this equation. And we're supposed to set this equal to what? We're supposed to set it equal to 2. Yay. Let's go ahead and set this equal to 2. and then we'll see what happens. Let's go ahead and do it here. And then we're going to cross multiply e to the ix plus e to the negative ix equals 4. Awesome. Let's go ahead and write the e to the power negative ix as 1 over e to the power ix using the rules of negative exponents. And then this calls for substitution. Yay. Let's go ahead and call this t. How about that? Te con leche. Okay. So we have t plus 1 over t equals 4. Multiply both sides by t. T squared plus 1 equals 4t. And then not 40, 4t. And now put everything on the same side. Then you'll get a quadratic. You can go ahead and add 3 to both sides. Then you will get a perfect square. Everything is awesome. Everything is perfect. And then from here you can take the square roots. Plus minus root 3. And then you can add 2 to both sides. You see how easy that is? Solving a quadratic by completing the square. That's also how you can prove the quadratic formula. Okay, but this is not the end of the story. This is just t, right? So how do we go back to x? We have to back substitute. How do we back substitute? Let's go back and see what happened. We said let e to the power ix be t. Okay, e to the power ix equals t. Let's go ahead and consider each of these values, or maybe write it as 2 plus minus root 3 first, and then I will show you how you can separate. That's something very interesting about this problem. But anyways, let's go ahead and do the work first. So I'm going to go ahead, I want to bring this down. So I have e to the ix equals 2 plus minus root 3. This is probably better to write it this way. And now I'm going to go ahead and ln both sides because of the e, and that's going to give me the result, right? Well, ix move to the front, and ln e is 1, so don't write it. Ix equals ln 2 plus minus root 3. But obviously, I want to solve for x, so I am definitely going to divide both sides by I, but dividing by I is so easy. It's pretty close to multiplying by I, because I squared is negative 1. Makes sense? So we're going to go ahead and divide both sides by I, but on the right hand side, I want to divide and multiply by I. Just an extra fraction I over I, which is 1, right? Okay. So what am I going to do next? I cancels out. I end up with x. I multiply the ln by I, like this. Negative, I times, I didn't say negative, did I? I times I squared is negative 1. Yes. Now I can go ahead and multiply the top and the bottom by negative 1. And that's going to give me x equals negative I times ln 2 plus minus root 3. And something very interesting happens here. Let me tell you. 2 plus root 3 and 2 minus root 3 are conjugates. Makes sense? So if I write the first root as negative I times ln 2 plus root 3, 2 plus root 3 can be written as 2 minus root 3 to the power negative 1. If I move this negative to the front, I get I ln 2 minus root 3. That is my first solution. The second solution similarly will give me I times ln 2 plus root 3, because I'm going to start with ln 2 minus and then negate it, so on and so forth, reciprocate it. So to keep a long story short, the solution can be written without the minus sign, and that is going to be without the minus sign, meaning that we don't need a minus I in front of it. So I times ln 2 plus minus root 3. The plus minus in the 2 root 3 is going to take care of everything. And this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.